Good morning, students. Today we are going to discuss about the last topic of the chapter motion, that is uniform circular motion. In the previous lecture we talked about equations of the motion. So we are having three equations of the motion. Very first we are having v equals to u plus at, second s equals to ut plus half of at square, and the third equation of motion we are having v square equals to u square plus 2as. Now today's we are going to discuss about the uniform circular motion. So firstly we'll talk about simply what is circular motion. Circular motion is a type of motion in which any of the particle moves in the circular path. If objects move in a circular path, that motion is defined as the circular motion. But when we talked about uniform circular motion is a specific condition of the circular motion in which the magnitude of the velocity of the object will remains constant or the same, but the direction of the motion will keep on changing at every point of the motion. That means if we define that condition in the term of definition, then we can say that if a body is moving with uniform speed, then it is said to be executing uniform circular motion. What is the definition? If object moving with uniform speed, then it is said to be executing uniform circular motion. So we are having many more examples in our day-to-day life related to the uniform circular motion, that is motion of a satellite in its orbit, or we can say that, and secondly we can say that motion of the planets around the sun. That means all the planets moving around the sun having a type of uniform circular motion. Now by the diagram, as we can say that before going before having the diagram, firstly we'll move to the some specific condition for having the uniform circular motion. So note, in this type of the motion, speed may be same throughout the motion. Speed means the magnitude value. Suppose if you are having 20 km per hour, speed 20 km per hour. So 20 km per hour is the magnitude. So this will remains constant. That means if you are having 20 km per hour, so throughout the journey we are having the value of this speed will be 20 km per hour. But the direction will keep on changing, but its velocity, that means velocity contains magnitude as well as the direction. So magnitude will remain constant, but the direction is different at each and every point. That means if we if we move to the one point to the another point, so at every point we are having the different directions of the motion. That means if we are talking about this point, so we are having the different direction. So how will we define the direction during the circular path? So at every point, at any point, if we draw the tangent along that particular point, so that tangent defines the direction of the velocity. That means if we draw tangent from this point, so this will be the tangent along the circular path. So this tangent will defines the direction of the velocity of the particle or the object. Now if we move to this point, so if we draw the tangent along this point, so that tangent will define the direction of the velocity. If we draw tangent from this point, so this tangent will define the direction of the velocity. So at every point, uh, if we are constructing any of the tangent along the circular path, that tangent defines the direction of the velocity. So what is the condition for the uniform circular motion? Speed will remain same. Speed will remain same. That means magnitude will remain same. That means if you are having 20 km per hour, so it will remain constant throughout the journey, but its direction will keep on changing at every point. Now, so that type of motion is under the uniform circular motion, and uniform circular motion, that's why it's defined as the accelerated motion also. Now the question is that if we want to calculate the velocity of the object during the uniform circular motion, so how will we calculate the velocity? So by the simple standard formula, as we know that velocity will be equals to the distance upon the time. So distance upon time. Now if we are talking about this circular path, so what will be the distance of this circular path? So that distance for this circular path will be equals to the circumference of the circle from this point to the this point. So what will be the circumference of the circle? 2 pi into the radius of the circular path. So circumference of the circle upon the time. So if capital R is the radius of the circular path, so what will be the circumference? 2 pi r upon t. That means if we are having the value of the radius of the circular path and time taken to cover that particular circular path, so that two values, with the help of those two values, we can calculate the velocity of the object during that circular motion. Then, so this is very important formula, and for the numerical portion this formula is very important related to the uniform circular motion. Now in the previous topic we talked about the equations of motion. Now we will talk about some numerical portion that is related to the equations of the motion. So very first we are having the numerical. A car starting from the rest moves with the uniform acceleration of 0.1 meter per second for 4 minutes. Find the speed and the distance traveled. So by the question, firstly we will write down all the given values from the question. So a car is starting from rest. So if any of the object is starting from the rest, so initial velocity of the object will always be equals to 0. With the uniform acceleration, so acceleration is defined symbolized by the small a. So what is the value of the acceleration? 0.1 meter per second in 4 minutes, that is time will be equals to the 4 minutes. Now firstly we have to calculate time into the second. So we can write down 4 minute equals to the 4 into 1 minute. So 1 minute equals to the 60 seconds. So when we multiply both the values, so we will get the value of the time into the second, that is the 240 second. Now we have to calculate the speed, that means the final speed, because initial speed is already given to you. Right? So firstly we will try from the first equation of the motion. So from the first equation of the motion, we are having the equation of the motion v equals to u plus at. So to apply this equation, we are already having these three values, so we can easily get the fourth value. So we will be equals to the, if you solve and put all the values in the equation, then you will get the 24 meter per second only, meter per second, sorry, by mistaken that is written over here, meter per second square. That is not meter per second square, that is only meter per second, because this is the unit of the velocity, not of the acceleration. Now if you are having the velocity value, and secondly we have to calculate the distance. So from first equation of motion we cannot calculate the distance, so we will move to the second equation of motion to calculate the distance. So second equation of motion, s equals to ut plus half of at square. So s we have to calculate, u already given to you, time is already given to you, and acceleration is already given to you. So by the putting all the values in equation 2, you can get the value of the distance traveled. So you can do the second part of the question to yourself and find out the value of the distance traveled. Then after that we will move to the question number 2. The brakes applied to a car produces deceleration. Deceleration means negative acceleration or retardation. Deceleration means negative acceleration or the retardation. Deceleration of 6 meter per second square in opposite direction of the to the motion if car requires 2 seconds to stop. After applying brakes, calculate the distance traveled by the car. Now firstly from the question we will write down all the given values. So firstly we will check what values are given to us. Deceleration of 6 meter per second square. Deceleration is always defined as the negative acceleration. So how will we represent negative acceleration? If value of the acceleration is in the negative form, that defines the negative acceleration. That means we can simply write down a will be equals to minus 6 meter per second square. Minus sign represents the deceleration or the negative acceleration. After that we are having 2 second. Car requires 2 seconds, that means time will be equals to the 2 seconds to stop the car. That means finally car will stop. Finally car will stop means final velocity of the object will equals to 0. So we can write down the values, t will be equals to 2 and v will be equals to the u. Then we have to calculate the distance. That means to calculate the distance we cannot apply the first equation of the motion, then we will move to the second equation of motion. But when we see the second equation of the motion, s equals to ut plus half of at square, to calculate to apply this equation of motion, we have to know the value of the initial velocity, because all the two values are given to us. So firstly, we will calculate the value of the u. So to calculate the value of the u from the above given values, we will place the first equation of the motion, because v is already given to you, a is already given to you, time is given to you. So we can easily calculate the value of the initial speed, initial velocity. So initial velocity, when you place all the values in the equation, then you will get the value of the initial velocity. now now we are having the value of the initial velocity. Now we can apply the second equation of the motion. So when we place all the values, the value of the u, t, a and t square, then we will get the value of the distance traveled by the object, that is equals to the 12 meter per second. You can solve the numerical, the calculation part to yourself. Then, so the answer of the S will be equals to the distance travel will be equals to the 12 meter per second. Now we are having the last question, that is related to the uniform circular motion. So a particle is moving. If a particle is moving in a uniform circular path of radius r, what would be the displacement after half a circle? That means we have to calculate the value of the displacement after half a circle. So we will move to the diagram. That is, diagram is given to you. Diagram is given to you, that is, A will be the particle journey is starting from the A, and at the point B the circle is half. So we have to calculate the displacement. So displacement will be defined as the shortest distance between initial and the final position. So initial position is A and the final position is B. So what is the shortest path? One path is this. This is the longest path. But what is the shortest path? From directly A to O and O to B. This is the shortest path between initial and the final position. Now we will calculate the distance between them. That will be equals to the O to A, that is R, O to B, this is R. So AB will be equals to the OA plus AO plus OB, that is R plus R, that is 2R. So by the help of the diagram, we can calculate the displacement of the particle after the half of the circle. So why we are calculating? Why we are not taking this path from A to B, this path? Because this is the longest path and this is treated as the distance from A to B, distance from A to B. But whenever we are talking about the shortest path, so this will be the shortest path. That's why we are not taking from the value A to B. We are only taking from A to O plus O to B. This will be the shortest path between the initial and the final position. And by the diameter of the circular path, we can calculate this value. Then, so this will be the last numerical, solve numerical or the extra numerical related to your topic. And now we are just finishing the chapter with this last topic, and rest of the NCERT exercise is left. So we'll talk about the NCERT exercise will be later on. That's all for today. Thank you.